Questions? Anybody have a question on the summary? Okay, go ahead.
It's just about like how we should write our answers. Like, if I wrote x is less than -3, is that acceptable?
Good question.
If I have
The reason of my test and the AP exam will be, on the AP exam, I'll go thoroughly through like all the format with you as the year wears on, and you'll be aware of what score you're shooting for and how easy it is to make that score if you're really following along in my class. But anyway, the reason you need to know different notations that I'm throwing at you, once we get really heavy into the derivative, for instance, there's different ways you can write it. The biggest reason that you do is because if somebody presents it to you, I don't even understand all their notations. When you get to the free response, I'm not a big fan of calling ever use, so sorry. It's just, I don't know. There's the things that come and go, and it's a free response problem. You know, I'm just saying that I don't feel super special calling it ever use. Anyway, on the free response problems, you can write whatever you want. You can write -1 TO, you know, like the word 3. I mean, we're looking for, you know, that you've got the right mathematical measures. And I've always graded like the AP readers do, but I've, now I'm actually there grading them. And I can tell you, I'm glad this is on video. I never listened to it. It is such a positive environment. I just got these ones. You would be amazed if I could take video. We can't take cell phone into the grading room, but you would be amazed to hear the group of, you know, like I'm grading on the format that they give us, and I'll show you how that works. You'll have grading standards put in front of you quite often. And I grade your test that way when you're doing a free response. But if you do something that I don't expect, or the grader next to me sees something they don't expect, they ask the person next to them, and then it goes to the head grader. And I won't belabor this point too much because of the test coming up, but you need to know how much we're in your corner. It's always the discussion is trying to give you a point. It's never, should I ever, I'm going to take this off. It's always, I've given this person 6 points, can you find 7? I don't know. You know, and you don't like to get back read like you're grading. The whole packet of tests goes up to the head graders, and they spot check them, but they thoroughly go through at least one of your stacks at the beginning to make sure you're grading correctly. They're very often sees it. You feel this kind of shadow behind your chair. You're sitting there with your friends grading, and you're like, they can't hurt me. But it's almost always that I made a mistake or my friend made a mistake, and I need to up your grade. Like, you gave this student 5 points, I found 6, so tell me your reason and we'll talk about it. But, and so I grade that way anyway, but, so in your free response, I have 9 points I'm looking for. You'll be well trained in how to write that. And so I'm looking to give you 9 points, and so we really don't care about the format or simplification. I'll teach you just to stop with your algebra. Like I told you the other day, y minus 5 equals 12 times x minus 2. Stop. If I distribute that and try to add it to the other side, that's where I'm going to mess up, and then I've got to count if it's wrong. So you'll learn to pause. I'll teach you to do a lot of things in its purest form, especially when you're calculating. So that was a long explanation. Sometimes you'll get things in interval notation from me or from them. Sometimes you'll get it in inequality notation. I do want to go in and talk about this. It brings it up. It came up in one of your problems. Absolute value is a really big deal. I kind of alluded to that the other day. There's a lot going on with absolute value, and absolute value seems so innocent. But you need to always think of absolute value as a piecewise function. Not always 2 pieces even, but the absolute value of x or x minus 3 or x plus 4 is just 2 pieces of a line joined together, okay? What's interesting about absolute value is one of the functions that does not have an inverse. That's why we stop and we stutter. We're just like, but what's interesting is the first time you ever saw it in your whole life, your teacher didn't say they were doing a piecewise function, but they were. They were said, well, what if x is greater than 4? What if x is less than? Well, they probably didn't go into that detail, but they would say, what if you have the absolute value of x minus 4 is equal to 6? first of all, you have total freedom in here to just say that the answers are -2 and 10. You do not have to do the algebra if you know the answer already, okay? Obviously, the algebra is going to come into play sometimes. I don't know the answer, and it says like sine of 3x minus 4 equals 6, and I've got to do some algebra all the way down. Not everywhere. There's usually no solution. But anyway, didn't your teacher say something like to do this? X minus 4 is equal to 6, and negative x plus 4 is equal to 6? Unfortunately, your teacher may not have done that. They may have changed the sign of the 6.
Yeah.
Okay, that's incorrect. That's a 6, okay? There's no reason to change the 6. What I would do is change the signs on the other side. That's what's really happening. Okay, for instance, if I have the absolute value of x equals 5, this is a 5. That's a 5. That's not factorial. I'm so excited. That's a 5. That's emphasis. I should just stars for emphasis. Factorials are taken. So anyway, but what could this be? Do you see the positive and negative is applying to what's on the inside? You're going, oh, this could be positive or this could be negative. Okay? What if you have the absolute value of x squared plus 4 equals 6? Apparently I'm stuck on 4s and 6s. You don't have to do anything to that. There's no reason to negate the other side. What is x squared plus 4 anyway? Okay, so let's back up.
Positive.
Yes. What does absolute value do to a negative number? What does absolute value do to a positive number? Good, I like that. I'm so glad you didn't say things that positive. That's what a lot of people say. I want you to say, when I say what does absolute value do to a positive, I want you to say absolutely nothing. Nothing at all. Doesn't affect it at all. So what you're doing here, when you break it up, is you're really being a little more clear. It's x minus, you're doing this case if x is greater than or equal to 4. And you're doing this case if x is less than or equal to 4. Okay? Because if I pick a number greater than 4, like 5 minus 6, 5 minus 4, 7 minus 4, aren't those positive numbers anyway? And so the bars were doing absolutely nothing, so I just have that expression. But if I put in a number less than 4, like 2, what do I get in here if I say 2 minus 4? Negative. If I put in 2 minus 4? Okay, now it doesn't equal 6. I'm just saying what happens if I put in 2 minus 4. I get a negative 2 inside. What do the bars do to it? Makes it positive. But I don't even like that notation. And it's not your fault. It's our fault. We tend to say x and negative x. I should never say that. Okay? Because it leads you to think that negative x is negative. It's not. If x was negative in the first place, then what is negative x? What does a negative do to a negative? Makes it positive. Okay, so what I should say is x and the opposite of x. This is this expression. If it's positive, I don't need any bars. But if this is negative, I need to totally change it to make it positive. All right, so let's deal with x is equal to 2. Just ignore the 6 for a minute. That just says x equals 2, even though it doesn't look like it. If x is 2, I get 2 minus 4, which is negative 2. Absolute value turns it into a 2. This one just takes care of it all at one time. Put in 2. Don't you just automatically get 2? That's because I know if this was negative, I need to take its opposite to make it positive. Okay? I'll come back to that one in a minute. And I'm going somewhere this with Caitlin's question that you need to know. You'll see it when you're there. Okay, so if I have the absolute value of x, y is equal to the absolute value of x. I don't want you to think of absolute value. Your teachers never had you undo absolute value. Your teachers don't know how to work absolute value. I mean, like, undo it. We don't know how. It's one of the weird functions that I can't undo and just square root both sides or divide both sides by 3. I can't get rid of those symbols. I'm stuck. So do y'all see that? There's not something I can slap on there to get rid of. One reason is it's not a one-to-one function, but that's not the only reason. Okay? Anyway, pause. Absolute value doesn't always make a b. Gauss and asymptote, little things like that we need to say. The absolute value of a linear function always makes a D. But the absolute value of a quadratic could make a W. Absolute value of sine makes a cute little scallop edge thing, okay? Because all it does is, whatever's negative, it makes positive, whatever's positive, it keeps. We'll talk about that real quickly. Obviously, I'm moving really fast. What I want you to do, always and forever, when you see this, is go, you know what, if this is a positive number, I don't need those bars. They're doing absolutely nothing. That would be true in this case when x is greater than or equal to 0. Then I make a note to self, if x is less than 0, this is going to be a negative number, so I need to take its opposite. Okay? Celine, give me a number less than 0.
Negative 1.
If she puts a negative 1 right here, what will she get?
1.
It works, doesn't it? Look at the picture, girls, of this piecewise function. You can include the 0 in either spot here, by the way. And we'll talk a lot about what we're going to do with our equals and inequalities. At 0, I get 0. Would y'all agree this is the line y equals x? If I put in a positive, hello, I get out a positive. And I just, whatever I put in, I get out. What does this look like? This piece is negative x. You've seen that before, right? It's not that it makes a b, that's not important to me. It's important to me that I understand what's going on with the graph. So that if I have something that looks like this, and I take the absolute value of it, I know that it's going to look like this. Do y'all see what I mean? So, y equals just plain little baby x is this. What does absolute value do to a positive? Absolutely nothing. What did absolute value do to the negatives? Took its complete opposite. Do y'all see what I mean? Okay, so that, I want to do this real quickly. X minus 4 looks like this. You see where it turned negative at 4? And so I have this piece of x minus 4. When x is greater than 4, it was going to be positive anyway. What's it going to do to this piece?
Positive.
It's going to make it positive. And so now, can you see I have a line with a negative slope that has a y-intercept of 4? And that happens when x is less than 4. So that's why it's happening. Now, I said all of that for lots of reasons. By the way, what's the square root of x squared?
Plus or minus that.
Okay. Some of you that have me will remember this, and this year you're going to understand it. When I told it to you in Honors Algebra 2, I don't know if anybody got it, but I went on and on and on because it's so important. Y equals x squared. Let's say if I'm going to solve, y'all help me solve x squared minus 5 equals, let's say 14. Okay, so let's throw in more than that. Hang on. I want to do a little bit more algebra. Okay, so help me solve this equation step by step. We're doing inverse functions, okay? So what would I do first? Add 5. All right, so 3x squared equals 27. What would you do next? Which, by the way, are one-to-one functions. There's no possibility I'm going to get like a different answer there, okay? Like what if I said sine of x is 1/2? Like there are lots of possibilities for that. X squared equals 9. Now, I don't want you to say anything because I don't want you to do what you've done in the past, okay? Because it wasn't right. Your teachers got you to the right point, myself included, but it was just such a deep issue at the time to tackle that nobody really explains it to you. I tried for my students, but I don't know how well I did. But you'll at least remember it. But now everybody's going to get what's going on. So Emma, like everyone else, said plus or minus, but watch this. I'm going to pause for a minute. At that moment, an honor student in Algebra 2 should have shot your hand up and on. That's not right. Because what's the answer to this? Well, not that, the next step. What's the answer to this? What's the answer to this? So you must believe that the square root of 9 is only what? 3. Do y'all know what the answer to that is? Only 5. But somewhere your algebra teachers, myself included, I'm not putting a finger at anybody, we confuse the heck out of you. Now you're like, I don't know if it's 5 or plus or minus 5. So all of a sudden you told me it was plus or minus 5 out of the blue one day, and now I have no idea what to do. Okay? The square root of 9 is 3. No one should ever have written, myself included, plus or minus 3. It's just, we got to keep moving through the curriculum. But now you're going to know how to do it right. Okay? They really weren't wrong. I'm being facetious. Some of you that have had me know that like I get really dramatic. But I'm being a bit facetious. But this is what's really going on. They skipped that step. I don't blame them. I did too sometimes. They just got too much to explain. Here you go. The square root of 9, girls, is 3. The square root of 25 is 5. Y equals the square root of x function looks like this. Don't we all agree on that? Yeah. Yeah. But I do a whole lot of blending together where you actually see what's going on, okay? Obviously, I'm always drawing graphs, okay? But, so you see what I mean? If I'm out here and x is 9, the only answer is 3. But we've confused you, and I need to unconfuse you for us to go on. Well, I just would have skipped this step, possibly. So, y'all are right. I slapped the square root on here. However, I've said this word a few times. That's not a one-to-one function. X squared. Aren't there more possibilities going on? So that, the left-hand side is the problem, not the right-hand side. The right-hand side is 3. And this was not x, and this was not plus or minus 3. You poor children, okay? Because we said x is equal to plus or minus 3. Didn't we go straight from there to there as your teachers? Well, the square root, that's wrong. The square root of x squared is not even x. And the square root of 9 is not even plus or minus 3, therefore you're in a quandary like, oh my gosh, I don't know what to do. Until I give it to you concretely, you do know what to do. Okay? Because we skipped this step. The square root of 9 is 3, and what's the square root of x squared? It was traveling down this side. This is the absolute value of x is equal to 3. What could fit in there? So it's coming here. So to take it a step more, it's really this issue. Couldn't that have been positive or negative x like I just showed you? So therefore, what would fit in here would be plus or minus 3. That took a bit of time, but you see it's totally necessary for us to keep on going through the year. To really understand absolute value, it's way more important than I ever thought it was as an algebra student when I got into calculus. So what's the square root of 16? 4. What's the square root of x squared? Absolute value of x. Okay? And you may sit there and wonder, well, why didn't they show us that? Those people that I subjected it to would probably agree that it was not a good idea. I think I just, does anybody remember me trying this?
Yeah.
Yeah, but it makes sense now with some maturity. I hope that makes some sense.
Yeah.
Okay. All right, so thank you. That's a good answer anyway. So you may wonder where I was headed with this towards summer work and issues that you've seen. You've seen like a piecewise function that says something like f of x. I can't remember if it's in summer work or your homework or both, but it might say something like where the absolute value of x is less than 1. Do y'all remember that problem you were doing pieceless finding? Oh, 12 on the summer work. Number 12. So Caitlin, all of that I had to go through. And I'm glad you asked that question because it reminds me to do number 12 because they'll do that to you in addition to interval notation and inequality. They'll throw an absolute value at you and you'll go, hey, what interval am I on, okay? So on number 12, we have y is equal to -1 if x is less than or equal to -1. 3x plus 2 if the absolute value of x is less than 1, and 7 minus 2x if x is less than or equal to 1. Our life is really made up a whole lot more of pieces than it is just like a quadratic or a, just like one graph. Our lives really travel through lots of different graphs from 5th Avenue to 82nd Street to 97th Street to you're at all different pieces throughout your career. So anyway, this is 7 minus 2x. Alright, so I need to know what this interval is. What in the world does this mean? The absolute value of x is less than 1. So they really could have written it as an interval, they just chose not to, but I need to empower you to understand what in the world they're talking about. What are some numbers in here that are less than 1? Okay, negative 1/2, positive 1/2, 0. I could draw a little number line, but I'm going to do this. It's either when x is less than 1 or its total opposite is less than 1. Would you agree? But from what I just said, you're always worried about this. Not worried. Playing with that, okay? Here's x is less than 1. What is this one going to become? X is going to become greater than negative 1. So what they were trying to tell you is this is the moment in time. If they give you that weird looking notation with the absolute value in it, you've got an inequality like this between negative 1 and 1. Do y'all see what I mean? It's greater than negative 1 but less than 1. And I'll go ahead and finish this one since I'm here. Negative 1, I always fill in these numbers first and put an open or a closed circle. Negative 1 gives me negative 1 and it's closed. And it's constantly, if I'm less than negative 1, I'm at negative 1. So it looks like this. Now I'm going to fill negative 1 into this, and I get an open circle, but I get an open circle at negative 1. And so it snaps onto this one. Please don't ever give me something like this. Okay, either the dot's there or it's not. Please don't draw a circle around the dot. It just snapped together like a pin top or like Legos, have an open and a closed circle, it's closed. Okay? So that one, this piece, 3x plus 2. That piece snaps right onto that and it's closed. Y'all see what I mean? It starts where, picks up where 1 left off. Alright, so it's closed, and then I'm going to go all the way to 1, 5. And then I have to be aware of what this looks like and show my teacher the shape. That's just a line, but if it was a parabola, I'd show some curve or something like that. So it goes straight there and it's an open circle at 1, 5. So that's open. Okay? Pretend like that's open. I've like pretty much closed it. Oh, well, that wasn't even good. Okay. Then I'm going to fill in 1 here. Oh, by the way, if I say x is greater than 1, don't go all the way to 2. Just go ahead and fill in 1 and start right after that. X is, oh, is this greater than or equal to? I must have copied that down wrong off my sheet. Hopefully that's greater than or equal to. Okay. And when I fill in 1, okay, and I fill in 1, I get 5, so it snaps on. And I find a couple other points, like if I fill in 2, I get 3. And it travels away like that. Okay, so you're now probably scared to ask a question because, you know, an hour later I finally answered Caitlin's. She's like, oh my gosh, I wish I had done that. Okay, there's a lot of information. I got to get something right.
All she said was, how do we write our answer?
That was it. That was all. Okay, but I would have done all of that anyway. It just fit right in. Okay, I promise no matter how tempting it is, I won't do that to the next question. I will just answer your question. I almost promise. Okay, next question on the summer curriculum.
Wait, but what was the answer? Like,
You can write it for me if it's open-ended. You can write it however you want. Okay. As long as you write something correct, I will count it.
What's the format of this test?
This test is I haven't created it yet. But most of my tests will be like, say there's 20 questions. It's kind of the, oh, I didn't tell you about the format of the AP exam. It's 45 multiple choice and 6 free response. So 45 multiple choice, and part of those are calculator and part of non-calculator in 2 different sections, kind of like the SAT or something, okay? Same for free response. So I will give you more multiple choice than I do free response on a test. So normally it's something like 13 multiple choice and 2 or 3 free response. Okay. So the format of this test, I haven't created it yet. I could look back at what I've done in prior years, but You'll have some multiple choice, which I don't think we really had much here, but, you'll have some multiple choice, and, it's hard right now to find, entire free responses, just because all you know is limits, and most free response problems, then the A part's a limit, the B part's a this, the C part's a that. So I think I can find a few that, ask you just to, find, I'll be able to find a few free responses that just go through limits and write the equation of the tangent line. Oh, you know derivatives, so I'll find a few. It's
Do
easier
we get
than-
the whole class or for class?
Oh, the whole class.
Okay.
Yeah. I do have to watch going into lunch because, some people have clubs and stuff on certain days, and it's just so not fair for me to let someone sit in here and keep going if you have to leave and go get ready for a club or meet with the teacher. So, be sure you're on your game when you come in. And I make, I've done it forever. I make the test to where if you know the material, you should be fine.
And also it's the whole worksheet, right? The summer worksheet.
Yes.
The whole thing.
If I cut any of it out, I'll decide during class today, or I'll send you an email. So expect an email from me telling you more clarification on what we're getting asked.
Okay.
And like, so do we need to know the, like, trig identities and stuff?
You always do, yeah. To a calculus teacher, that is like, because that's a class you've had.
Yeah.
So to us, I understand your question for sure, but to us, that's like asking, do I need to know how to factor?
Yeah.
You've got to know your identities, but that comes into play in doing your homework. I don't really have students that are really doing their homework on an ongoing basis. Granted, you've got to look over for your summer work, your kind of rest and kind of stuff. But if you're doing your homework, anything to me could come up that you ever had in there. And so that's why I'm saying really focus on your homework. You do need to know your identities. Sine squared plus cosine squared is 1, sine squared cosine tangent. I mean, don't freak out over it. You're probably okay. You know the ones you need to refresh your memory on. Does that make sense? If you need like a succinct place for identities, I think you could probably have them yourself, but send me a note and I'll send you what I call a memo page. While she's saying that, I'm asking it, I'll bring it up another day because I tried to say I wouldn't, well, it could come up, sorry. So, the two that I'm most worried about that you need to know all year, that you probably don't know because you learned your double angle identities close to the end, and so you just didn't do them as much. They're not harder, okay? Sine 2x can be made into a single x by saying 2 sine x cosine x. And you need to know the double angle identities. And then Caitlin's question comes into play, like, if you ran into that or that, on free response, I don't care. On multiple choice, though, they might have answers you're not expecting because they worked in identity. Cosine 2x starts out as cosine squared minus sine squared. I don't hardly ever use that one in favor. By substitution, do y'all see what can I put in for cosine squared? 1 minus sine squared. So that's where your teachers got 1 minus 2 sine squared. And if I did that with this one, couldn't I also go back and do it with this one? That's 1 minus cosine squared, which gives you this behind the minus sign. It creates this. These are super important, especially second semester. But cosine 2x can be turned into something that you can then work with some more. And integral calculus, we have a lot of restrictions on this. There's a lot of things we're not going to know the antiderivative on. That's why an integral is not an antiderivative, because I can still work an integral even though I don't know how to go backwards on a function, but that's further ahead. So you do need to know your identity. So look at your list or send me a note, send me an email if you want me to send you a list. But I expect you to know and then how to work with an algorithm. Sorry about that. Okay, other questions?
There was a bunch of questions in the 20s where you have to find like like multiple values of x.
Yeah.
I kind of like once you like solve it and have the answer, I forget how to like find.
Are we on 22 through 27?
Yes.
Pause for a minute. Let's go back to something we ended the last last class on, right before the 20s. So, number 18, x squared minus x minus 12. Do y'all see that I could factor that and do the little plus minus chart? Are y'all okay with that?
Yeah.
Okay, if I had x squared plus x minus 3 is greater than 0, I can't factor that. I don't think. I hope I made up when I couldn't factor. Doesn't mean that it doesn't have places that's greater than 0. Okay? So let's look at it on the calculator. And myself and the AP, I had the calculator up. Where'd it go? Did y'all see the calculator? I'd already pulled it up. Let's see. Anyway, we know when to give you your calculator and when to hold it away from you, okay? You will have, if you can't factor something, you will have your calculator, all right? What I would do here is use common sense. Like I said earlier, pictures are worth a lot. I wish there was a way to clear all of these out. Oh, I'm hitting enter instead of clear. Let's see. That took me like a long time to figure that out. Okay. So what was my equation I made up? Does anybody remember?
X squared minus, oh yeah, plus x minus 3.
Minus or plus?
Plus x minus 3.
All right, plus x minus 3. Okay, and I'll graph it on the standard viewing window at first. I also want to say this real quickly. Is that ever greater than 0? Okay. Something we'll work on later. I know that you feel like you probably need to work on your calculator skills. But I can actually see when it's greater than 0. It's greater than 0 right here. And right here. Sorry, I didn't really land on it. Do y'all see? I can actually see where it's greater than 0. Okay? That's what a plus minus chart would have given me, that plus minus plus scenario. So I'm not going to be giving you things I didn't give you on summer work. It's just a time and a place to say that. You can find those. I'll remind you of some calculator skills. Second calc 0. A few of you have done that. I don't know if everybody has. There's buttons on your calculator where you can find the zeros. Always give me answers to 3 decimal places. Okay? All right. Now, if you have your calculator, go on and get it out because I'm going to show you a setting that you probably already have. And unless I did this the other day. Did I have this did I pull this up? Are y'all, go to second table set. I'm going to have to fix this one. You want to be on ask. Let's all get there. Some of you probably already are on independent ask. Like this. That's what you want. I don't care what these two things say at all. It doesn't matter. You need to be on auto ask. Don't panic your table. Probably just clear it out. But that's okay. So second table set. Here it is right here. The buttons will light up when I push them. So you want to go to second window. Second window. And everybody take a moment to get on Ask Auto. Okay. And I'll say a few reasons why that's real important. You'll have to fill in lots of numbers like square root of 7, that if you're on ask, auto, I don't really know where you would find that. You're in total charge of what you fill into your table now, and you'll use table more than you maybe have in the past.
Oh,
Also,
I tried to do that in the past and it just never worked.
there you go. Now it works. Like I can go to table now and just fill in whatever I want to. Oh, I think I could touch the screen. So now if I want to fill in like 65.2, it'll do it for me. Also, you remember all that, this is one of the most important things I'll say today. You remember all those times, especially maybe in rational functions or polynomials, you're like, I don't think the whole graph is in my meeting, but I don't know where it is. Table's your new best friend, okay? If you're going, I don't know what this graph is, go to table and ask. If you're going, I don't see what's going on, put in 7. If it says 30, then you automatically know how to reset your window. That's where it is. If you find yourself on the test or homework, like, oh, I don't think I'm seeing the whole graph. That's table. Okay? All right, so now let's go in the 20s. So that was just a little blurb on if it doesn't factor. All right, so does anybody have a specific one in the 20s you'd like to know work? I'm going to work 23 and 24, okay, because they're similar, but I would work them differently. You've got to be a great decision maker, but I mean, I can't imagine what you're going to do in life where you don't have to be a great decision maker. Somebody could be sitting on the examination table and you're a doctor, somebody could be sitting across your desk and you're a lawyer, somebody, you know, could be wanting your financial advice over the phone and you've got to give it right then. And you're going to have a wealth of knowledge and you can pick and choose. So you've got to be really good decision makers. Sign up, and by the way, sometimes I'll make a decision and I'm free to change it. Don't freak out if you went the wrong way, okay? This one to me, I could change this, like I was just harping on, to choose sin x cosine x. But I think I'm pretty stuck there. When I tried that maybe with a student, they did come by and ask me a question about this problem. It just doesn't really get you anywhere. To me, I know where sin's -1, so I just did u substitution. I said sine of u equals -1 to just calm down and I can think about it for a minute, okay? I think you all did u substitution. Okay, you'll do a ton of it in here. That's like a temporary Band-Aid. It makes it hopefully an easy problem for you. However, let me say this. What's the period of sine 2x? Pi, thanks, Sophia. Pi. I want the answers on this from 0 to 2 pi, so Sophia better go around again. If there's a 2 there, I'm going to go around again, okay? Because I'm going to have two things happen during that time. If there's a, God forbid, a 4x in there, I'm going to have to go around my unit circle 4 times and list all these answers and then go back and divide them all by 4. Should ring the bell on all our honors classes. We all did that, okay? So I know where sine is -1 at 3 pi over 2. This, I'm just dealing with you. I'm pretending like it doesn't even say that, okay?
Did you 2x?
Yeah. Thank you. I get so carried away. All right. Okay. So first time around, sine is -1 at 3 pi over 2, or if you're looking at a sine graph, Sophia, out to pi, it's -1 right here. This is wrapping around, this is pulling it out as a graph, okay? But you see I better go around again. What I mean by go around again, right now I'm just dealing with this, so I just add 2 pi to that. That takes me to 7 pi over 2. Isn't 2 pi 4 pi over 2? And if it had a 3 there, I would add another one. What's a little unique about this one is it landed right on an axis. I didn't have like 2 answers my first time around. You know, like it said sine of u is 1/2. I would say pi over 6 and 5 pi over 6. Then I would go around again and add 2 pi to it. Even though the period's not 2 pi, I'm going to take care of that in a minute, okay? So what I've done is I've treated it like a lazy sine wave. I just went, oh, it's 3 pi over 2. Then I revolved again and got 7 pi over 2, okay? But now I'm going to take the Band-Aid off. I'm going to take u out and put what back in? 2x. And then what will I do with the whole thing? Divide it by 2, you would say probably, but that's going to be really ugly. So I'm going to multiply by 1/2. Doesn't that make more sense here?
Yeah.
So that's going to give me 3 pi over 4 and 7 pi over 4. And this barely makes it in, doesn't it, between 0 and 2 pi?
Yeah.
So you see how what happened is I made it just this easy, lazy sine graph, and then when I divided by 2, you see it switched it down into the period that I needed. So find a whole bunch and then divide it down, okay? All right, now let's compare that to number 24. All right, 24. Now I've got another sine 2x equals cosine x. And I don't want a sine of u equals a cosine of x. I don't want that to happen. And so there's a lot of things I want to say about this problem. This is 2 sine x cosine x equals cosine x. if I was a really loud person, I would start screaming at the top of my lungs right now to warn you, danger, 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 danger. Do not divide by cosine x. It's one of those weird feelings where you're looking at the teacher going, but you taught us to do that. If you divide by a variable expression, you're opening a window and throwing out a bunch of answers. Do not divide by a variable expression. Girls, if you could divide by an expression, what else could you have done instead? If it'll divide, it'll factor. Okay, good answer. All right, so I have 2 sine x. It's tempting, isn't it? But you would have just thrown away a situation. A lot of these kind of things, boy, that's really ugly. A lot of these kind of things won't factor in trig for us. You got to think that happens in real life. And then so we'll look at a picture on our calculator and we'll be able to see where it equals 0. Haven't had to do that under summer work, so I'll stay away from that right now. Okay? I'm going to factor out a cosine x, and then this gives me 2 sine x minus 1 equals 0. Set your factors equal to 0. It's an endurance sport. Sine x equals 1/2. I'll move really fast. Are we okay? Yeah. All right. Cosine is 0 at pi over 2. And at 3 pi over 2, and sine is 1/2 at pi over 6, and 5 pi over 6. And if you looked at it on the calculator, interestingly enough, you would see all of those. I have to do a quick double check and make sure that there's nothing that is going to be undefined in the original. Because once I've taken algebra stuff, by the way, that's another thing I need to say to you is, I probably said it to my honors class, and Mr. Knowles probably mentioned it too. Those extraneous roots that you would get, those things you have to go back and cross out that are so aggravating, and you look in the back of the book and go, I forgot to cross that one out. I've said it to you the other day, be aware of your domain the whole time. Sine and cosine are continuous everywhere. I'm not really worried about this problem about extraneous roots. But if that's a tangent, I'd have to go back and check and make sure it's defined in all the places. Once you take an algebra problem, once you take your first algebra step, you're not even working on the problem I gave you. That's how extra roots can creep in. If I give you a square root, aren't there heavy restrictions on it? Heavy restrictions. Like half the numbers are out of play. What's your first step if I have a square root? You square both sides. What do you just do? You just open it up to a lot of people that may not belong in there, that you've got to go back and make sure they fit in the original. Okay? Alright, so I have no idea to answer your question, Morgan. Were you the one that was asking about 20s, the 20s? Okay, do I need to do something else in the 20s?
I don't think so. Also, I had another question.
Okay.
I don't remember how to like find the period if it's not like 2 pi. Like what?
If you have y equals a sine or cosine b x, it could be sine or cosine. And this is disregarding all the shifting that can happen. This is stretching. This is the amplitude, and you can take it at face value. Really, if the amplitude has a -3, the amplitude is just 3, but it starts underneath. To find the period of sine or cosine, you say 2 pi over that number. If it's tangent or cotangent, you say what? What's the period of tan and cotangent? Pi over. I taught it with my fingers. Tan and cotangent are little small pi. Their period's pi. This period's 2 pi. And my brother only has how many fingers? Y'all read that? Anyway, that's a sign. So he could do this with his left hand like I can. Anyway, tan and cotangent are these little people. Tangent's the weird one, by the way. This is all your CSCs. Change, challenge, and shape world. This is sine, cosine, secant, cosecant, cotangent. All of these like start and count out. Tangent's that weird one that you split up into the middle. Do y'all remember counting the little this way and the other? Tangent's just, it's still short, period's pi, but it's the one that you graph a little differently than the others. But they look kind of like, they're both square. Yes. All right, other questions? All right.
First, the parametric equation.
Okay, parametric?
Yeah. So for number 15,
Yeah.
parameter,
Okay.
I got an answer, but it's not.
Okay.
It's,
Maybe I
when
missed.
you like remove the parametric, like the parameter.
and then I got sine, cosine, inverse.
Yeah, that's what I did.
Okay, time out. Good point. You don't want to, and you both, so it's just different teachers are showing up right here. I think y'all both had Mr. Hill, not that mom got it. I'm not gonna ask him. So, yeah, I'm not gonna ask him. Well, I'm greater than Mr. Hill all the time. Y'all know we have like a huge war going on, along with Mr. Walters, not such a peaceful person. And Mr. Hill is like light years smarter than I am. He's better.
You're also very calm people.
Yeah, we are. We're like him. But I'm just always totally teasing her. Don't tell him that I do respect him. It's like an unbelievable teacher, but never. Ever. Because if you do, then I'll hear about it. So anyway, I'm not a fan of solving both for t and setting them equal to each other in the first place. Like on number 53, on 53, you have x is equal to the square root of t, and y is equal to t minus 3. I would just say t is equal to y minus 3, and then I would just sub that in for t. Like a lot of times I'll just solve one for t and sub it into the other. I don't really care if you're getting them right, what you're doing, but sometimes I'll just talk about different things you can do, so be open-minded. I had to be open-minded because I'm super stressed. All right, anyway, on this, ironically, you don't want to solve it all the way down for t because it gets super ugly and it just doesn't even make any sense really algebraically. And so when we're doing it this way, I'm going to say x minus 1 over 2 equals cosine t, and y plus 1 over 3 equals sine t. And then I know this math fact that sine squared plus cosine squared equals 1. Okay, so then what can I put in for, what can I put in for sine?
You can put cos, that 1 minus cos squared t.
Oh no, I'm just going to put this in. Sine t.
Yeah, it's gonna be x plus 1 and y minus 1.
Did I mess something up? Oh, x plus 1.
Yeah.
Is it right now?
That's all.
Yeah.
No, it's
There
not.
should be a y minus 1.
Yeah, that one is y minus 1.
So this must have been plus?
Yeah, that's a plus.
Good grief, I must be. Oh. Okay, sorry, I get all wound up. Alright, so I hope you know where I am, because obviously I don't know where I am. Sine can be replaced by that statement. Sine of t explicitly equals that. And so I have y minus 1 squared over 9. Cosine is x plus 1 squared over 4 equals 1, which is a conic section. It's an ellipse, which makes perfect sense with my points. Yeah, that's sort of where, usually you study conic sections in algebra and pre-calc, but our block scheduling is along with math and everything. I wish we had more time to spend on that. Here's a quick little synopsis of it. Use common sense as much as you can. So Emily and Morgan, y'all especially watch this. What's your most important number here? Treat it like a factor. Negative 1. So I know my center is negative 1, positive 1. Why did I go to that one first? Because what letter is it? Follow your letter. Follow your variable. I will say that all year. Follow your variable. So my center is negative 1, 1. X means I'm going to be moving across. It's all squared, so I'm going to move across how far? 2. Out 2 and back 2. And then I'm going to go from my center, I'm going to go underneath my y, follow your variable, up 3 and down 3. And this plus sign makes it an ellipse, it's going to pull it together. If it was a minus sign, it wouldn't pull it together. What would it do? It would send it apart, like a hyperbola, okay? but you were right, if Y comes first, it would pull it apart this way. If X is in the front, it pulls it back. On a hopper. Don't even think that much on it already. Girls, I'm not finished with this problem though, because it's parametric, I have to show the direction. That's why when you look at your little table of values, I think I listed my table. As I found points, I started at the time the clock was ticking, I started at 1, 1. And then my next point was at -1, 4. So I know that this one is going this way. In parametrics, you've got to show the direction arrow by finding a few points. Number 55 is tedious, so, and we're out of time, so, I have until 11:40. I don't know if I want to spend time doing that. Let me say that we are not going to have polar coordinates, we're not going to have polar on the test. I didn't want to tell you that until now, so I wanted you to work really hard on this, and it's easier when we get to polar later in the year. But in second semester, I'll give you a little recap of polar, like a little 10-minute recap of polar, and then we'll go on. But polar's not on the test. And I'll send out probably, let me make myself a note about that. And I'm still talking, I'm gonna go straight up to 11:40. Hopefully not 11:41. So don't go anywhere. So no polar. And hopefully I'll look at my notes to sell extra practice. The reason I'm gonna send out an email is it could be very likely that Grace and Anna don't need to listen to the video and they don't even know where to go in the place to find out more about the test, so that's why you might see an email about it also since they're not here. Now, one huge thing I have on my list to tell you today is always be in ratings. I will show you probably next class, probably not this class, but really, for y'all kind of way too much for me. That makes me very happy. I'm so sad. I'm going till 11:40. Don't pack up. I'm going to talk about your worksheets and stuff. Calculus does not work in grades. I could have calculus in grades. It would be a lot uglier, ironically, than calculus in maintenance. And you would have to have a completely different textbook. So nobody does it. Because why not do it easier? The derivative of sine in radians is cosine. If you're in degrees, it's like 0.017 cosine. So when you rather do it the easy way. I'll show you why, okay, in case you want to know why, because so many people don't care. Also, I'll probably show you at some point. But always be in radians, always, okay? Because your derivatives won't work that way and your intervals won't work. So if you will quickly get out your limit worksheets, or at least pay attention to me while I get out my limit worksheets. I'm going to call out the answers to you. And by Wednesday, and I'll send all this to you. By Wednesday, I will have wanted you to work 1, 2, and 3, but by then you would have got more instruction from me and you can just pace yourself. If you want to just only study for the test for Monday, that's fine. And then Monday night, maybe watch a little video that I would have explained some more about this, and then work all 3 worksheets for check. But I'll lay all that out for you. If you don't get an email from me, you don't have to do it. All right, I hope you just wrote good words on 1, 2, and 3. There will be some explain later on in the year. 4A, 3. 4B, 2. 4C, -2. 4D, D and E. 4E, 1. F, -1. G, -1. H, -1. I, -3. 5. I would accept D and E or infinity. That graph is going on to infinity, but we would accept either one. Mr. Hill and I both, I think, said D and E does not exist on limits, but you all have very little practice on limits. But I would accept either one. B, hang on, let me call it the answers. B is D and E or negative infinity. C is D and E or more specifically negative infinity. D is, I just wrote positive infinity. E is negative infinity. F, you have to say x equals. Anybody want to give them to me? Caroline?
X equals -9, x equals -4, x equals 3, and x equals 7.
Okay, Morgan, question, okay.
Oh, I was just gonna say for I think there wasn't a value in there. Like it was a little open
It's
circle.
just teeny tiny on mine.
Okay,
It's
yeah.
like an open, it's a dot. It's supposed to be a closed dot.
Okay.
You're not gonna
Oh,
get
now
a,
I see
yeah,
it.
you're not gonna
I see
get a
where
really
is that
ugly
coming
graph like
from?
that on the test. I'll make sure it's clear. Okay, number six, as x approaches 12 from the left is 150, 12 from the right is 300. I'll talk about that one on the video. 7a is 1, b is 0, c is d and e. You have to be doing the same thing from the left and the right. 8, hopefully you sketch that graph. 9, I gave you 9, didn't I? The number should have gotten closer and closer to 3 if you were in radians. Was anybody in radians and it got closer to 3? Okay, a lot of people are looking like real synonymous. Do you think you were in degrees maybe?
Yeah, I know.
Anyway, you might want to try that one again. The 10, you might want to venture a guess what that should have gotten close to? 0.5. 1A on worksheet 2 is 5, B is 9, C is 2, D is -1/3, C is -3/8, F is 0, G is D and E, H is -6/11, 2A is 2, B, D and E, C 0, D, D and E, E 16, and F 2. Up to this point, aside from the trig ones that we just spoke about a second ago, this kind of stuff is good to look at for the test also. So let me know if you have a question about it, but I'll do a video on this, okay? And send it to you sometime soon. All right, guys.